This video is for the solution of question number 3 and 5 in your workbook on page 91 for Kirchhoff's rules. So in this circuit we have this three branches, as you see. So what we need to do is first let's name these currents. So let's call this one I1, that one I2, and that one I3. We need 3 equations for the 3 unknowns. The next thing we have to do is to assign directions for these currents. So I am guessing that I1 is in that direction, I2 is also entering that junction, and I am guessing I3 is what comes out of that junction. That gives me my first equation, because if I1 and I2 are entering that junction, I will have I1 plus I2 equals I3. Then based on my selections of these currents, since I chose I1 to be in that direction, it is moving upwards on this resistance. So I label this side plus and that side minus, because those will be the polarity for current to go from plus to minus. I'll do the same for this resistance. Since I chose I2 to be flowing upwards on that branch, on that resistance it will be flowing upwards, so plus to minus, and my I3 is going down on that resistance, so from plus to minus. Now that I've decided on the polarity for the resistance, I'll just add those for the batteries. Those are clear from the diagram. The long end is always positive and the short end is always the negative. Now I'm ready to write my loop equations. So first I'm going to go with this loop right here. So I'll start from that point and then go in that direction here, come back where I started. And I feel like I'm looping clockwise. So let's start here. The first element on that loop is the 10 ohm resistance. If I'm looping clockwise, I am going from its minus to plus side, so that is a voltage rise of 10 I2. The next element I hit is the 6-volt battery, and I am passing clockwise from its plus to minus end, which would mean a voltage drop of 6 volts. That brings me to the 12-volt battery, and for this one on my way I pass from its minus to plus, which is a plus 12 volt in my equation. And the element of the 5 ohm, I am passing from its plus to minus, which is a voltage drop of 5 I1. I am back where I started, so I end my equation. Let's write the third equation using this loop on the right, and just because we can, let's loop the other way, starting here, because why not? So if I start here, the first element I pass through is the 9 volt from its minus to plus, so I write that as a positive 9, that's a voltage rise. Then I reach the 12 ohm element. Again, I'm passing from its minus to plus, so that's another rise of its resistance times its current, which would be 12 I3. The next element on that loop is the 10 ohm resistance. From its minus to plus, another rise of 10 I2, because that's the current passing through it. And the last element is a voltage drop, because I'm going from its plus to minus, so a drop of 6 volts. I'm back where I started on my loop. So the blue loop was that, from here and then here. So that's my 3 equations as I get from the physics of it. So let's solve these equations. The way we need to put it in our calculator is I1, I2, I3 and the coefficient. So the first equation, let's just number them. That would be our third equation. Our first equation I can write as I1 plus I2 minus I3 equals 0. My second equation, I have a minus 5I1, I have a 10I2, I will still write the I3 term because I want to be able to see its coefficient. Obviously, I have 0 I3 term in there. And on this side, this minus 6 plus 12 makes a plus 12, but I'm throwing it to the other side. Sorry, that it makes a plus 6. Moving to the other side, that is a minus 6. And rearranging the third equation, I get 0 I1 plus 10 I2 and I have 12 I3. The constant terms is 9 minus 6 on this side, which would be a 3. Moving to the other side, that gives me a minus 3. So now that I have rearranged my equations ready to go into the calculator, my matrix is going to look like this. 1, 1, minus 1, 0, minus 5, plus 10, 0, minus 6, you get 0, 10, 12, minus 3. When you hit solve, you will get the answers of I1, I2, and I3, and you will actually get a negative answer for I2, which means it wasn't flowing upward on that resistance, it was actually flowing downward. So the circuit runs, the I1 goes in, splits into I2 and I3 over here, and I2 and I3 join back here and connects to I1. You will get I1 equals 0.44, I2 equals negative 0.38, and I3 equal to 0.07. As I said, that means I2 is flowing downward on that branch with 0.38 amperes. So this is how the circuit is flowing. Let's look at number 5. Let's name the 3 currents that we need to find. Let's call that branch I1 and say that that is going into that junction. Going also into that junction, let's name that current I2. And leaving the junction, let's call that I3. So I3 is flowing that way on the 2 ohm, I1 is flowing that way on the 3, and I2 is flowing that way on the 6. While we're at it, let's decide the positive negative ends of the resistors. So if I1 is to the right, we label from plus to minus. Let's do the same thing here. We decided I3 is flowing to the right, so we label this side plus and that side minus. And it will be this side plus and that side minus because we showed I2 going up on the 6 ohm. So complete that for the batteries as well. Now we're ready to write the 3 equations. My first equation will be the current equation using that junction. I know I1 and I2 are going in, so I'm able to write I1 plus I2 equals I3. And then I am going to go with the loop on the left. So let's go counterclockwise and start from that point. First I pass from the 3 ohm resistance, and that's a voltage rise from its minus to plus. That's how I'm passing. So 3 I1, and then I pass from, so let's draw the loop how I'm going. So I did that, and then I'm going downward, and by downward I mean from plus to minus end of the 9-volt battery. So that's a voltage drop of 9. Complete the loop, keep going until you hit a circuit element, and I'm passing through something from its plus to minus end before I come to my initial position, that would be 6I2. And that's my second equation. And my third equation is going to be on the loop on the right. Let's just randomly decide that we're looping counterclockwise again. And let's start from this point first. So I am passing through a 12-volt battery, passing from its minus to plus end. So that's a voltage rise of 12. And then I pass through the 2 ohm resistor from its minus to plus end again, so that is another rise of 2I3. The current on it is I3, so its voltage will be 2I3. And I will complete by passing through the 6 ohm 6I2 from its minus to plus. That's how I'm passing, so that will be a plus 6I2. I am back where I started. My equation is done. To solve this, my three equations. Let's rewrite them with a different color. That's my first equation, that's my second equation, and that's my third equation. So my first equation, I rearrange all the i's on one side, which would be I1 plus I2 minus I3 equals 0. My second equation will be 3I1 minus 6I2. I have a 0I3. And I move the 9 to the other side as a positive 9. Write the third one. No I1s. I have a 6I2. I have a 2I3. And negative 12 on that side, because this goes to the other side as minus 12. So, solving that, what you would put into your calculator would be 1, 1, minus 1, 0, 1, 1, minus 1, 0, 3, minus 6, 0, 9, and 0, 6, 2, minus 12, which will give you solutions for I1, I2, and I3. And actually, you're going to get 0 for I1 and a value of 1.5 for both I2 and I3. What that means is this. So in our selection, if we choose I3 to the left and I2 down, we should get positive 1.5. So the current is flowing counterclockwise. What we chose was the opposite. So the solution to these equations should give I2 and I3 both minus 1.5 amperes, and it should give I1 equals 0. It's going to look like that circuit. Let's play that again. So that's the solution. Thank you.